Guys, this is Michael from Study Simple again. In our last video we discussed how to take the derivative of a basic function. Well, this time we're going to go a little bit more in depth with that and introduce taking derivatives when you have addition and subtraction in a function. So to get started, we're going to come up with an example function. We'll try this right here. Use the same function we had from our last video, 3x to the fourth power, but now we're going to add on to that. We're going to say plus 7x to the third power minus 5x to the second power plus 27. Okay? Now, if you remember from our last video, we had a form for taking the derivative of a basic function. That form was dx of a to the x to the power of n equals a times n x to the n minus 1. Okay? Well, when you're taking a derivative of a function, if you have addition or subtraction within the function, you can actually break that into its own separate derivative. So we can literally take the derivative of this, the derivative of this, the derivative of this right here, and the derivative of this, and add them all together. So then what it's going to come out to is something that looks like this. d dx of 3x to the fourth plus d dx of 7x to the third. We got our subtraction sign here, so minus d dx of 5x squared plus d dx of 27. Okay? Now, each of these fits into the form of our a to the x minus n. Alright? So we're going to start here. We're looking at it. We've got our a as 3 and our n as 4. So following the form, we've got 4 times 3 to the x fourth minus 1 plus, in this one, our a is 7 and our n is 3. So then we have 3 times 7 to the x 3 minus 1. Got our minus sign here. Just bring that down. Then in this one, our a is going to be 5. And then our x, we've got to the second power, so our n is 2. So we open up here. We've got 2 times 5 x to the 2 minus 1. Then we've got our addition sign here. Now, we didn't discuss this in our previous video, but anytime you take the derivative of a constant, it's simply going to be 0. Because this is the same thing as 27x to the 0th power, because anything to the power of 0 is simply 1. So if you multiply that 0 in front, just like you would up here, 27 times 0 is going to make the whole thing 0. So we rewrite this here. We get 12x to the third plus 21x to the second minus 10x to the first. And that's going to be our derivative f prime of x for this entire function.